Chapter 3, Section 3. We're going to bring in some new terminology with graphing, something called intercepts, and then we're going to use those to help us graph lines which represent the solutions to equations with two variables. And then we're going to talk about some special graphs that happen when we have horizontal lines and vertical lines. Well, this first word is intercept, and it's kind of a modification of intersect. And intercepts are where we have an intersection with the axes. So the y-intercept is a point where, in this case, this line, this solution line for this equation 4x plus 2y equals 12 right here. If I put in three solutions in the way we learned how to graph before, I could put 0 in for x, and I get a result for y of 6. So 0, the ordered pair 0, 6 is a solution to this equation. So that ordered pair is called the y-intercept. And again, if you think about what's going on with every point on the y-axis, the x-coordinate, the x value, the horizontal change, right, is the first number, is 0. There's no change horizontally. So every ordered pair, I could pick any ordered pair that not necessarily solutions to this, but I could take every ordered pair and the x coordinate, the first value in my ordered pair is always 0. Well, if I look at the other one, if I have a point on the x-axis, well, every point on the x-axis, the y-coordinate, or the second number in the ordered pair, which represents vertical change, is 0. So if I put 0 in for x here, I end up at 2y equals 12. Excuse me, I got that backwards. If I put 0 in for y, you get 4x equals 12, and solve that for x, you get 3. In other words, the ordered pair 3, 0 is a solution to this equation. Well, and it's called the x-intercept because it is where this solution line crosses the x-axis. And that's what they're pointing out here. The x-coordinate of anything on the y-intercept, or they could say any ordered pair on the y-axis, the x-coordinate is always 0, and the y-coordinate is 0 for anything on the x-axis. So even when things are not linear, we can look at intercepts, or things where they cross the axes. So this example 1 for the graph shown below give the coordinates for any x-intercepts. So what are they asking for is where does this solution parabola, it's called, where does it cross the x-axis? That's what x-intercepts are. So we're looking at this point here, this ordered pair where this parabola crosses the x-axis, which would be negative 2, 0. I should already know that the y-coordinate is 0 because they're looking for x-intercepts. Well, it has 2 in this case. It comes over here 2 at 2, 0. Okay? Now, y-intercepts, there's only one. There's only one place where this graph intersects with the y-axis, or that y-intercept, and that would be at 0, because every point on the y-axis, the first ordered pair will be 0, and then a positive 4. So they want to make sure you're real clear about identifying what x-intercepts and y-intercepts mean, and what would they look like on a graph. Can you identify them with their ordered pairs? So based on this understanding of what intercepts are, there's some relationships between the ordered pairs, no doubt, right? So we're going to use intercepts to graph. So first we have to find the intercepts. To find the y-intercepts of a graphing in an equations graph, you would replace the x-coordinate, or the horizontal change value in your ordered pair, with 0, and then solve for y. Why can I do that? Well, for this to be on the y-axis, all ordered pairs on the y-axis, the x-coordinate is 0. So I put that in, and then see if that equation for that line crosses the y-axis. Now there's a possibility, and we'll go through that a little bit later, that it doesn't cross the y-axis. But in this case it does. So they put 0 in for 2x, and you get 2 times 0 is 4y. So you solve for 4y equals 20, and solve for y, and you get y equals 5. In other words, the y-intercept is a point. It's still an ordered pair of 0, 5. To find the x-intercept, well, everything on the x-axis, every ordered pair on the x-axis, the y-coordinate is 0. So if I put 0 in for y and then solve for x, I'll find out what that ordered pair is. And that's what they do here. So you'd get 2x equals 20, and then solve for x, and you get x equals 10. So the ordered pair 10, 0 is the x-intercept for this equation. Example 3, it says graph using intercepts. So we have these two values that we're looking for, where it crosses the y-axis and where it crosses the x-axis. And to do that, we know we're going to have a 0 really there, right? And we can get those values by putting a 0 in for x, and you'll get the y-intercept, or put a 0 in for the y-coordinate, and you'll get the other solve, and you'll get the other ordered pair for the x-intercept. And that's what they're showing there first on that graph to do this. Now, here we have 2 points. Here's the y-intercept and here's the x-intercept. Well, with that I could take a straight edge like the edge of my phone and draw that line. Well, what we did before is that if I made a mistake on that, I still can always draw a line through 2 points, but it's good to do a third point and make sure that it falls in the same line. If it doesn't, then I've made some error in how I'm solving for the intercepts. So do that third point to check. Example 4, let's look at it. It says graph 3x minus 2y equals 60 using intercepts. Then find a checkpoint, that third point. To find the y-intercept, and you need to do this even when you're what I do like about my math labs, if it asks you to graph with intercepts and you put a point that's not one of the intercepts and draw a line on your math homework or on a test, it'll count it wrong because you're not following directions. And that'll happen later when we get into slope-intercept form, which is probably the best way to graph lines. So make sure that you read the directions. In this case, we want to graph, and it says use the intercepts. So it would expect on the graph an ordered pair with a 0 for the x-coordinate, which would be your y-intercept, and it'll expect a point with the y-coordinate on another ordered pair being 0, which would be your x-intercept. So they expect you to do that. Put 0 in for x, you end up with negative 2y equals 60, so y equals negative 30. So that would make the ordered pair of 0, negative 30. Now on the grid, you would be expected to actually plot that point as you're drawing that line. Now the x-intercept, the y-coordinate is 0, so you put 0 in for y, and you end up with 3x equals 60. Solve for x, you get x equals 20. So we end up with this 20, 0 is the second intercept, the x-intercept. Okay? And then they talk about that third point again by putting in a number that hopefully will be in the scale, or basically in the grid of your coordinate plane, to check that. And that's what it shows here, is how to check that. Now technology is there's actually graphing calculators, and they do a lot of that for you, but in this class we're not using those yet. Now they're going to look at some special situations where we can graph a line And when I look at example 5, I'm going like, well, I got y equals 3. I don't have any values for x. Well, multiplication of 0 comes into this um, as a strategy, really. It says we can regard the equation y equals 3 as 0 times x plus y equals 3. No matter what number we choose for x, we find that y must be 3. And it creates ordered pairs. And when I put it in this form, I can say, well, I can put an x value in here. I get 0 times negative 2, and I get plus y equals 3, and I get y equals 3. Well, I end up with the order to pair negative 2, 3. Well, if I put 0 in for x, I end up with y equal to 3. If I put 4 in for x, I get y equal to 3. If I put 1 million in for x, y will be equal to 3. And now the next thing too, I get a lot of students try to memorize or try to get an idea of when they end up with vertical or horizontal lines, and I'm going, okay, why don't you do your ordered pairs and see if they work? Or you could draw that line, and if you made a mistake, you could take the ordered pairs off that and see if they make the original equation true. So they plot 3 of these points. They end up with this horizontal line up there would be that. So in this case, if I was talking about intercepts, and I asked you what is the x-intercept for this line, your answer would be there isn't any. There isn't any x-intercepts because this line runs parallel. In other words, it never intersects this x-axis. What is the y-intercept? Well, that's that point where it crosses the y-axis, which would be 0, 3. Now let's look at graph x equals negative 4. Now notice they use that 0 again, and they say, well, we could look at this as x plus 0 times y equals negative 4. Now I can put a value in for x and find out what y would be. Well, or probably it'd have to go the other way. If I put, because the only value I can put in for x is negative 4. But I put a value in for y, I could take negative 5, 0 times negative 5 is 0. And I end up with x equals negative 4. Again, I could put 1 in for y, 3 in for y, 1 million in for y, and my x value will have to be negative 4. Well, plot 3 of these points and see what I get. I get this vertical line right here that does that. So if I ask you for the y-intercept for this line, there is none. There is an x-intercept that crosses the x-axis at negative 4, 0. But there's no y-intercept because it runs parallel to the y-axis. And what they can kind of give us is some hints or some patterns that happen here. Again, I think if you just put that 0 in front of the variable you don't have and multiply, that's a way to represent that. Then it at least gives you a pretty solid foundation on how to check ordered pairs to see if you got the right line. But here they're telling us that if you graph y equals b, where b is just some number, you end up with a horizontal line through the y-axis at that value b, whatever that number is. So if I had y equals 5, 0, 5 would be the y-intercept, and it'll be a horizontal line. That's really all I need to know to graph this thing. But if I forget that, I can still create ordered pairs and see if they will make the original equation true. In other words, do I really have solutions for this equation? And then it gives us this shortcut for if x is equal to some number a, then it ends up being a vertical line with the x-intercept at a 0. So if I had x is equal to negative 5, right, I would end up with a vertical line with negative 5, 0 as the x-intercept. And I already know it's a vertical line, so I can draw it. So they want us to look at a graph that they give us, a graph of a line, and write an equation for that. So in this case, this is the y-intercept is 0 or 0, -2. So what would be the equation for this one? Well, I end up with what happens with every ordered pair here on this. There's no vertical change, so it's always -2, right? -2, -2. Whatever ordered pair I have, if I put 1, -2, that has to be on that line. 2, -2, 3, -2, 4, -2, and so on. Well, the only way that's going to happen is that the y coordinate, or y, has to be equal to -2. And then I'd have, like, I could put 0 times x plus y equals -2. Or y equals -2. Well, in this case, I have a vertical line. I'm going to have x is equal to 1. I can go through all that ordered pair stuff again. But these seem to have a lot of confusion around these things. But if you just test ordered pairs, remember what solutions really mean. You can always take whatever you think the equation is and see if those ordered pairs that are on that line will actually work in the equation that you just created.